Hi everybody, my name is Anais Ollagnier and I'm currently in a postdoctoral position at the University of Exeter, United Kingdom. In this presentation, I will briefly present the models that I propose as a part of the task 1, multilingual information extraction, introduced during the eHealth Lab evaluation campaign. So as a part of this evaluation campaign, I focus on the two subtasks proposed in the task 1, ICD-10-CM and ICD-10-PCS. In order to develop the proposed model, I have approached the task as a multi-label classification problem with a particular interest, considering the inherent characteristic of the corpus in handling the class imbalance problem. In total, I've proposed 5 models during the official evaluation, all based on a convolutional neural network and a long short-term memory network, also known as CNN-LSTM classifier. In detail, the first proposed model refers to the baseline, which consists in a simple CNN-LSTM architecture. In the second model, I have leveraged a powerful language model multilingual BERT as a part of a sequential transfer learning scenario. Here, the pre-trained language representation MBERT is introduced during the pre-training phase, and then the CNN-LSTM architecture is applied during the adaptation phase to fine-tune models to the target task. In the third model, WordNet, I have explored a traditional textual data augmentation technique consisting of a word-level transformation, also known as a synonym replacement. The process of synonym replacement is implemented as a preprocessing step in a data generator pipeline. That means that for each batch, 10% of documents words randomly selected are substituted by WordNet synonyms, except stop words. Finally, edited documents are used to feed models relying on CNN's LSTM architecture. Concerning the next model, WordNet MBERT, this model is based on the two previous approaches, also implemented as a preprocessing step of the data generator pipeline. Synonym replacement is based on the same setup as in the original approach. 10% of documents word as substitute. Then, as introduced in the MBERT approach, models are trained as a part of a STL scenario. And concerning the last model, TextGen, TextGen rely on a data augmentation technique based on a text generation method. The proposed data augmentation pipeline consists in 2 stages. Pre-training phase, in which a language model is learned from the given training set, and a generative phase, during which a pre-training language model is used to generate artificial data. In detail, the pre-trained language model is built using n-gram modeling approach, which allow to estimate n-gram distribution probabilities learned from a given corpus. The language model are trained for both tasks using the CNN-LSTM architecture. Then, during the generative phase, the appropriate pre-trained language model is introduced to generate artificial data as a preprocessing step in the data generator pipeline. In detail, that means that 30% of each document is altered for each mini batch. Formally, each document is split into sentences. Then 30% of the documents of the sentences are replaced by synthesized data. Concerning the official results reported here with regard to the mean average precision, MAP, the F1 score and the F1 score CAT, as we can observe, the result obtained depend on both the task and the model used. For the CodiEsp task, the WordNet model achieves a best map, followed closely by the model based on the pre-trained language model MBERT. For the F1 score, the WordNet model also obtains the best performance against the other proposed method. And for the F1 score CAT, the baseline is first rank, slightly outperforming the WordNet model. For the CodiEsp task, the best map is obtained using the combination of MBERT and the data augmentation technique based on synonym replacement, while the TextGen model achieves the best performance for both F1 scores. Concerning the unofficial results in italic font, the model WordNet is first rank on the CodiEsp task, while the TextGen model is the less efficient for the CodiEsp task. In the overall evaluation, the use of a STL-based architecture combined with a pre-trained model has shown its efficiency, outperforming the baseline on both tasks and the majority of evaluation metric. Concerning data augmentation technique, despite missing evaluation, the proposed technique produced strong results in comparison with the other models, outperforming both the baseline and the model based on MBERT on both tasks on the majority of evaluation metrics. Thanks for your attention, and don't hesitate to contact me if you need further information.